This week you're going to learn about average versus instantaneous rate of change, or average versus instantaneous velocity. Practically, guys, we need to remember that the derivative gives us the slope of a function, but it also gives us the rate of change, or how displacement changes with respect to time. In other words, rate of change, it's the slope. It's how much one variable changes with respect to another variable. So with that in mind, guys, if I'm talking about average velocity or instantaneous velocity, I'm talking about a rate of change. But there's a difference between average and instantaneous. The average velocity is that. It's the average of velocities in a specific amount of time. And instantaneous velocity is the velocity that something has at a specific moment, at an instant. So to find the average velocity, what we would have to do, guys, is use the formula of slope. So let's take a look at this example. A diver jumps from a platform at time t equal to 0 seconds. The distance of the diver above water level at time t is given by, and this is a formula that gives you the distance, where S is in meters and t is in time in seconds. Find the average velocity of the diver over the given time intervals. This is practically telling you your time 1, your time 2. You need to find the displacement or the distance at time 1 and at time 2 so that you can use the formula for slope. You're going to do that for all three of these. These are like different. Those are different intervals. So the average velocity is a change in distance over the change in time, which that's the slope. So we would have to find the displacement whenever you have at 2 seconds, the displacement at 1 second, over the change in your time. And practically it's the formula for slope. We do that for all of them, guys. Displacement evaluated in 2, in 1, in 1.5, in 1, in 1.1, in 1, in 1.01, and in 1. And these are my average velocities. The next question asks for the instantaneous velocity at time equal to 1 second. What that is saying is, what is the velocity that the diver has specifically at 1 second? And to do that, guys, we use the derivative. The derivative of my displacement is going to give me the velocity. And if we evaluate the time that we want in the derivative, what we're doing is we're finding the velocity at that specific time. And in this case, we would get negative 4.9. So the difference between the average rate of change and the instantaneous rate of change is that the average rate of change would practically be finding the slope of the secant line, while instantaneous rate of change, it's finding the slope of a tangent line. The secant, it's practically changing your y's over changing your x's, or in this case, it would be your displacement at a specific time minus the displacement at your initial time over your final time minus your initial time. And the instantaneous, it's the derivative of my displacement. Another example would be, during 1 month, the temperature of the water in a pond is modeled by this function, where time is measured in days and C is measured in degrees Celsius. Find the average rate of change in temperature in the first 15 days of the month. What this is saying is I want the average from day 0 to day 15. And letter B, it's asking for the rate of change in temperature on the 15th day. So to find the average rate of change, we would have to substitute the 15, because it's our final value, into C, minus your 0, which is the initial evaluated in C, over 15 minus 0. And that would give me the temperature, the average temperature during those days, the average rate of change during those days. And the instantaneous rate of change, we would have to find the derivative of the formula that was given for temperature. And then once we have the derivative, that's going to give us the velocity. So on day 15, the temperature is dropping at a rate of 0.243 degrees Celsius per day.